Graphing a linear function on a restricted domain, well, first of all, we need to understand what a linear function is. And a linear function has x to the first power in it with no higher powers. So there's no x squared, for example, no x cubed, etc. So a linear function has x to the first in it, or whatever the input is. If the input's t, it'd be t to the first. Okay? And when you graph these, you get a slanted line, a sloped line. So keep that in mind. To graph a slanted line, or any line for that matter, you simply need 2 points. So we'll sort of adopt this approach, graphing it by using 2 points, by plotting points. But you might want to review at this point y equals mx plus b. It's called slope-intercept form. You could also use that to understand these functions. Alright, let's look at some examples. So we have the function f of x equals 2x plus 3, and it's a linear function because this x is to the first power, and there are no higher powers of x. So we need 2 points to graph this line. So we'll look at, let's say if x is negative 2, for example, what would y be? Well, y would be 2 times negative 2 plus 3, and that's negative 4 plus 3, which is negative 1. So if x is negative 2, y is negative 1, we get this point. Let's look at another point, maybe further away. So maybe like if x is, let's say 3, then y would be 2 times 3 plus 3, which is 6 plus 3, that's 9. So if x is 1, 2, 3, y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we know it's a line. It's a slanted line, in fact. So all we have to do is connect these, and we've got every single point on this graph. Okay? So this is the graph of that equation. Now we could restrict the domain of this. Let's say I wanted to graph f of x equals 2x plus 3 only if its domain is, let's say, less than 0. So the way to do that would be to come back here and only keep the parts of this graph that are less than 0. So clearly, I'll graph it in red. Clearly we would graph from 0 to the left, where x is 0 and to the left. So all of those points are on this graph. And then we don't include the point where x equals 0, so we need an open circle here, not a shaded circle. So the graph of this function is in red here. And so if we just clean it up here, this is the graph of this function. We've cut off the parts that are bigger than or equal to 0, and we have an open circle here because x cannot equal 0. And that's it.